I haven't really done anything for this problem. I just don't know how to do it.
Okay, so do you know that, for example, it says this line, we should have this line should be, the graph should be symmetric about this line, right?
Yeah.
What does it mean? For example, y equals x is this line, right?
Yeah.
So if you, for example, consider x1, y1, if you reflect it about this line, it goes to what?
y1, x1.
Yes, so it means what? If this function be symmetric about this line, it means what?
X equals ay plus b over cy plus d.
We cannot say that. We can say, for example, look, if we calculate inverse of this function, do you agree it should be equal to, for example, suppose f of x? If you consider inverse of f, then it should be equal to f again, right? Agreed?
Yeah.
Because you switch y and x, like here. In f of x, you switch y and x, then you should reach again same. For example, it is something like this, for example. Or something like this, so we can say that. Now, we know y is equal to ax plus b, cx plus d. Calculate f inverse of x, okay?
X equals b minus yd over cy minus a.
You should say in terms of x, so it will be what?
Oh, in terms of x. And then you do y. I isolated x and then I switched them, right? So y equals b minus xd over cx minus a.
B minus x over cx minus a?
Yeah.
Okay, so let's check. Here, when you want to find inverse, we should switch x and y, right?
Okay.
One approach is this. And then you say cxy plus dx is equal to ay plus. So y times cx minus a is equal to minus dx plus b. So y is equal to minus dx plus b over cx minus a, right? Okay, so look here. C and D shouldn't be 0, right? Because it is they are, and the problem says CD are not both 0, right?
Yeah.
So because of C and D equal to 0, it is bad. It is the first thing we should pay attention. And why is this? And because we have inverse of f, so what condition should be satisfied here?
I don't get what the inverse of the function has to do with this
Look,
condition.
I want to say that f of x should be equal to f inverse of x. They should be same. Why? Because the problem says if, for example, p, suppose p prime, when you reflect it about this line. Do you agree when if p belongs to f of x, then p prime also belongs to f of x?
Yeah.
And do you agree when p belongs to f of x, p prime belongs to f inverse of x?
Yeah.
Okay, and do you agree they are equivalent? If p prime belongs to f of x, p belongs to f of x. If p prime belongs to this, right?
Okay.
So do you agree f of x should be equal to f inverse of x? We can prove it also by contradiction, by this approach. My claim, so let's prove this. My claim is this: f of x is equal to f inverse of x. Okay, we want to prove this. And it is not hard. Try to prove this.
Wait, so is it just that f of x1 is equal to y1 and f negative 1 of x1 is also equal to y1?
So at first, can you explain your approach is what for proving that fx is equal to f inverse of x?
Well, if I have a point x1, y1 and it's symmetric, then also the point y1, x1.
Yes, we want to prove, for example, xy belongs to f of x if and only if xy belongs to Now suppose x1, y1 belongs to this if and only if xy, y1 belongs to f inverse of x. Okay, so if you prove this, it means these two functions are same, right?
Yeah.
Okay, let's prove it. Then x1, so we want to prove this. Okay, so x1, y1 suppose belongs to f of x, and we know f of x is symmetric about y equals x. So what can we conclude? Because it is symmetric about y equals x.
Y1, X1 is in fx.
Belongs to f.
Mm-hmm.
And by definition of inverse of function, y1, x1 belongs to what? F inverse, right?
Uh-huh.
So do you agree we can conclude what from here? We want to prove x1, y1 belongs to f inverse of x. How can we prove it? From here, do you agree by inverse of function we can say x1, y1 belongs to f inverse of x?
Okay.
Okay, so here we don't need to, we can apply it here. So do you agree if a point belongs to f of x, it is if and only if the point belongs to f inverse of x?
Yeah.
So we prove this. But under what condition a function has inverse?
Like vertical line test was like only.
Yes, it should be one to one or injective,
Yeah.
right?
Yeah.
So now we should first check under what condition it is injective. So f of x. If f of x is injective for example, which A, B, C, D injective or one to one? For which A, B, C, D we can say it is one to one. Try to consider this.
I can't think of when it wouldn't be one to one. Like,
It is not always one to one, but for example, you can say for these A, B, C, D, it is one to one. Okay, want hint or want to try on your own?
like a vertical, like an asymptote at cx plus d equals 0.
Um,
Mm,
yes, there are different ways for checking that. For example, yes, one way is that you consider not for not vertical line, horizontal line, right? You can suppose, for example, suppose f of x1 is equal to f of x2, okay? And then analyze this and see, okay, for which ABCD we have this, and x1 is not equal to x2, okay? You can consider this and say, okay, what condition should be satisfied between ABCD to have this? Then we can conclude that for another case, it will be inject. Understand?
okay.
Okay, check this one. See under what condition between ABCD we have this.
I got when AD equals BC, but then that.
Exactly. If AD is equal to BC, then it is not injected, right?
Yeah.
Okay, so let's check.
But
Yes.
injective just means. Wait, so only when you say this, you mean only for every output, only one unique input, right?
Let me write it to make sure and check it. You cross multiplied, right?
Yeah.
Then AC x1 x2 plus AD x1 plus BC x2 plus BD is equal to AC x1 x2 again plus AD x2 plus BC x1 plus B. Then we can cancel these two terms, and if we take all things to one side, it will be AD x2 minus x1 plus BC x1 minus x is equal to 0. So we can say x2 minus x1, AD minus BC is 0, right?
Mm-hmm.
So we can divide by this because x1 is not equal to x2. So if you have this, AD minus BC is 0, right?
Yeah.
Okay, if AD is not equal to BC, we don't have this equation because by considering this equation, we will reach that AD minus BC is 0, right?
Mm-hmm.
So if AD minus BC is not 0, it is injective, right?
Yeah.
Okay, and now let's see when AD equals BC what happens. So let's,
It's a line.
yeah, it will be constant, right?
Yeah.
AX plus B, CX plus E. We can multiply,
Because
we
A over
can
C goes B
factor
over
from,
D.
we said what?
Because like A over C is equal to B over D, so then you can like divide it, right?
Yes, here AD is equal to BC, so A over B is equal to C over D, right?
Yeah.
But one thing here, maybe some of them are 0, right? So we
Mm,
cannot divide them, right?
well, C and D are not 0.
C and D are not 0. Both of them
Yeah.
cannot be 0. One of them can be 0, right?
Not both 0.
So let's consider different cases. If C, so let's consider if some of them equal to 0. If C is equal to 0, then D is not 0. Then we can conclude what is 0 if AD is equal to BC. I want to consider this.
Well, A times D is also, so A also has to be 0.
Exactly, because D is not 0, here is 0, so A is 0. So f of x will be what then?
B over D.
Yes, in this case it's constant, right?
Yeah.
And when a function is constant, obviously it's not symmetric about this, right?
Yeah.
Because, for example, it is something like this. It is not symmetric about y equals x. Now let's consider, so we can consider in case 2 c is not 0, okay? If d is
Mhm.
0, then what can we conclude?
Then B is 0.
Exactly. So f of x will be what?
Uh, A over C,
Yes, but x shouldn't be equal to what?
0.
0. So it will be, for example, something like this, right? Okay, again, it's not good function for us. So for
Mm-hmm.
third case, we can conclude C and D both are not 0, right?
Mm-hmm.
Okay, then we can say what? We can say A over C is equal to, for example, B over D, right?
Yeah.
Okay, so then we should do what to prove it's constant? Do you agree we can factor from A
Okay.
over C?
Yeah.
Then it will be Cx plus what?
A over C is CX plus uh, D. CX plus D.
BC over A, which is D, right?
Yeah.
Okay. Here we can say what? Here we
CX
can
plus
say it
D.
is equal to Cx plus D. They are equal. We can say it is A over C. But we should pay attention to something. Because we used over A, let's check 3, case 3 too, which is A is not 0. If we check case 3, 1, if A is 0, what can we conclude?
If A is 0, uh, B or C are 0.
Because what in this case 3, we said C and D are not 0 because we checked C 0 here and D 0. So C and D are not 0. So we can conclude what is what?
B is 0.
Yes. So f of x is what?
0.
Yes, again constant. In this case also constant. So if it is not 1-to-1, it means it is constant, right?
Yeah.
Okay, it is not only for this problem. In all problems, in all functions that have this form, we have these things. AD minus BC it is somehow similar to determinant. They call it, for example, A, B, C, D. Then AD minus BC equal to 0. It's determinant of this matrix, right? Okay. Now that we know these things, we know f of x should be equal to f inverse of x, and we found this one. We know c shouldn't be equal to c and d. Both cannot be 0, right? Because of this function, because of f of x, right? Because of f inverse of x, which two variables both cannot be 0?
A and C.
A and C. Next condition, A and C both cannot be 0. So let's try it. If A equals C equal to 0, okay? So now let's write the things that are important. This one, and also AD minus BC shouldn't be 0, right?
Yeah.
Okay, so then we should use casework and solve this. Want to try the rest on your own?
Okay.
Want hint or want to keep trying?
Hint.
Okay.
I don't know this way.
We said that f inverse should be equal to f, right?
Yeah.
F inverse is this one, right?
Okay.
And f of x is ax plus b over cx plus d, right?
Okay.
And so, have you considered this equation or not yet?
I have.
Okay. Were you able to reach any good conclusion from this equality?
No.
So, if we cross multiply, then do you agree we have two polynomials that are equal for infinitely many values?
Okay.
So when two polynomials are equal for infinitely many values, what can we conclude then?
They're the same polynomial.
They are same, means corresponding coefficients are equal, right?
Yeah.
Okay, and you can conclude three important results. Want more hint or that's enough?
I'll try.
Okay.
I don't get how to do it.
Okay, so let's cross multiply. It will be ac x squared minus a squared x plus bc x minus a, right? Is equal to minus cd x squared plus bcx minus d squared x minus d squared x, then what? Plus bd, right?
Okay.
We can cancel what from both sides?
BCX.
Exactly. And now we want to consider corresponding coefficients. Let's consider coefficient of x squared. Then what is equal to what?
AC minus A squared equals negative CD
No,
minus D squared.
no, why ac minus a squared? A squared is coefficient of x, not x squared.
Oh, sorry. AC equals negative CD.
AC is equal to negative CD, right? If we
Yeah.
consider coefficient of x, what can we conclude?
Negative A squared equals negative D squared.
Yes. Negative a squared is equal to negative d squared. What about constant term?
AB equals negative DD.
Negative AB is equal to BD, right?
Yeah.
So from the first one, what can we conclude?
A equals negative D and C is not 0.
So we can say C is equal to 0, right? If C is
Yeah.
equal to 0, they are equal. Or if C is not 0, you can divide. And you can say A is equal to negative D, right?
Mm-hmm.
Okay. Now, we don't need to say C is not 0, because if C is 0, also it can be equal to negative, right?
Mm-hmm.
So we have these two cases. From this one, what can we conclude?
A equals plus minus square root of D.
Absolute value of A is equal to absolute value of D, right?
Okay.
From here, what can we conclude?
A equals D or A equals negative D. Oh, from this one.
No,
Uh,
this one, this.
yeah, this one. B equals 0 or A equals negative D.
Yes, because here, look, we have this condition is satisfied, or this one, or both of them. At least one of them should be satisfied, right?
Mm-hmm.
Okay. Now we can say what? We have these three conditions, all of them should be satisfied. And also, we know that these three conditions also should be satisfied. We have these things. And we should calculate it by case. Want more hint, or that's enough?
I'll try.
Okay.
I got B.
You got B?
Yeah.
Okay, yes. So let's check this. Because in all of them we have A negative D, or A absolute value of A is equal to D. We can consider two cases. First case, A is not equal to negative. If A is not equal to negative D, what can we conclude?
A not equals. Can I do my casework? I don't. That's not.
Your casework is correct. You reach this. I want to
Yeah.
solve it with another casework to see, for example, two solutions. Okay?
Okay. Okay.
If A is not equal to negative D, look, because we have this condition here, and also it is similar to this one. So if A
Yeah.
is
So
not equal to negative D, what can we conclude?
C equals 0. B equals 0.
Exactly. C is equal to 0, B is equal to 0. Let me copy the other conditions that we have. We have also these three conditions. So let's consider them here. Okay, so because C is 0, we can conclude what?
D is not 0.
Exactly. And
A
what
is not
else?
0.
A also
A
is
is
not.
also not 0.
Okay, AD minus BC shouldn't be 0. Then what can we conclude?
Um. Then there's just. Well, because BC is always 0, so this. What's it called? This doesn't really.
AD is not 0 because
matter.
A is not 0, D is not 0. So this condition is satisfied, right?
Yeah. Yeah.
Okay, now we know all of them can be from 0 to 5. So how many case for B has one case 0, B has one case, sorry, C. A has how many cases?
Uh, 20, or it'd be like.
Their
It'd be just
absolute
20.
value are less than or equal to 5.
Yeah, maybe -5 to 5. Wait, but then it would be like. Okay, so 10. Yeah.
Yes, 10 cases. What about D?
And D would have 2 cases after that.
No. D has how many cases? Let me check. Sorry. For
Well, D, can
D,
I
A
do
has 10 cases. We don't have any condition between. Here, because this condition should be
No,
satisfied.
D
So
is
what
A or
can we
negative A.
conclude?
D is A or negative A.
A is not equal to negative D. So we can conclude what?
Why do we have this case? Okay. So then A equals positive D.
Yes. So for D, how many cases do we have?
10 or 1.
1. So in this case, we have 10, right? If A is not equal to negative D, right? Now let's consider
Yeah.
this case. If A is equal to negative D, we know all these three conditions will be satisfied, right?
Yeah.
So we should only pay attention to these three.
So you have another case.
Okay, A is equal to negative D. Because we are working with 0, let's consider two cases. Case 2, 1. Suppose A is equal to negative D and they are equal to 0. Case 2, 2, A is equal to negative D and they are not 0, right?
Mm-hmm.
In this case, because A is equal to negative equal to 0, what can we conclude?
A minus D equals negative D equals 0. There's 10 cases.
So, what can we conclude about BC?
Well, BC is still equal to 0. So that condition is satisfied still.
A is 0, so C is not 0, right?
Yeah. Wait, what is that?
Okay.
I don't understand how you're doing these cases. You have A equals negative. So is C still equal to 0? But it can be a case where A equals negative D, but C is equal to 0, B is also equal to 0. That can still
Look,
be a
here
case.
we consider only A is not equal to negative D, we consider that. Now we consider A is equal to negative D, so I consider two cases. A is equal to negative D equals 0, or A is equal to negative D and is not equal to 0. Understand the case for it?
Okay.
So when A is equal to 0, obviously because this condition is not satisfied, C is not 0, right? If you consider
Yeah.
again this one, C is not 0. And if you consider this one, what can we conclude?
B is not 0.
B is not 0. Okay. And also here, we know AB minus BC is not 0. Okay, so let's consider cases. So for A, how many cases do we have? One case, right? Because it is 0. For D, one case. What about C and B? How many cases do we have for C and B?
You have 10 each.
10 each. So it will be what?
100.
Yes. So 10, 100. First, 1 second. Now let's check that. A is equal to negative D, they are not equal to 0. So this condition is satisfied, this condition also is satisfied, right?
Mm-hmm.
Only we should pay attention to this condition, that AD shouldn't be equal to BC, okay?
Mm-hmm.
We can use complement rule. Here, can you tell me for ABCD, if we don't consider this, in the end we will subtract this. From this one, how many cases are there for ABCD? For A, how many cases are there?
A has 5 cases.
No, why 5?
Or 10. Well, 1 to
10?
5 and then negative 1 to negative 5.
Yes, 10 cases. What about D?
Well, D just depends on A.
Yes, so when you determine A, D has how
So
many
1.
cases? D 1.
1.
What about B?
Then I gotta do casework. Or B and C, I gotta do casework on A, right?
No. You remove this. If you didn't have this condition, how many cases do you have for B?
11.
Yes, and 11, right?
Uh-huh.
Minus number of cases that AD is equal to BC, right?
Okay.
Okay. We know AD is equal to negative D squared, right? This shouldn't be
Okay.
equal to BC, agreed?
Yeah.
So, we consider cases. Case 1 here, if D is D squared, negative D squared, BC, D is what? D is plus minus 1. Okay. So in this case,
Mm-hmm.
BC shouldn't be equal to negative 1. Here, we are using, let's consider this complement rule. So BC is equal to negative 1. How many cases do we have for this case?
2.
For A and D, we have 2 cases. For B and C also, we have 2 cases. 1, negative 1, negative 1, 1, right?
Yeah.
So you have 4 bad cases, right?
Mm-hmm.
Okay, now if you consider next case. D is equal to plus minus 2. Then BC is equal to what?
-4.
Yes, calculate how many cases do we have here.
6.
No, try it.
Sorry. Well, 2 times 6 because of the D case.
Yes, 12 cases, because we can say 1, -4, -4, 1, right? -1, 4, 4, -1, right?
Mm-hmm.
2, -2, -2, 2. So 1, 2, 3, 4, 5, 6. 2 times 6, 12. If we answer case 3, D is equal to plus minus 3, so BC is equal to 9, -9. How many cases do we have here?
2 times 2.
Yes, it's 4. Because 3, -3, -3. Case 4. D is equal to plus minus 4. So BC is equal to -16. So how many cases do we have?
2 times 2 is 4.
Yes, because we can only write 2 minus 4 minus 4 minus 4, 4, because they are from -5 to 5. And last case, D is equal to plus minus 5. So BC is equal to -25. How many cases do we have?
4.
Exactly 4. So if you add these numbers, 4, 4, 4, 12, 12 plus 12, 24, 24 plus 4, 28, right?
Mm-hmm.
So it will be what? 1, 2, 1, 0 minus 28, which is what?
1292.
1292.
Wait, that's 1282. Oh, but there's also the 10 other ones that we didn't count for.
So this is what?
1282.
1282. 1282 is greater than 1210.
Or sorry, 1
Yes.
1182.
Yes. Okay. So 1182 plus 100 plus 10. So 1182 plus 100, and it will be 2921, right?
Mm-hmm.
So the answer is this, right?
Mm-hmm.
Okay. You use casework on what?
I just said C equals 0, B not equal to 0, C equals 0, B equals 0, and then C not equal to 0.
Oh, yes, there are infinitely many ways to use casework, but the most important thing is to consider these 3 conditions and then find these 3 conditions, right?
Mm-hmm.